Good morning, class. So today we are going over chapters 102.7, which is the pH scale. It's not a very long chapter at all, and it will go a little bit more in depth over the next couple weeks with the pH. So the question of the day is, have you ever washed your face with soap and it felt like it was getting a little tight and dry afterwards? And usually this will happen with certain bar soaps that some clients will use on their face. So when you guys get to the consultation portion, that'll be explained a little bit more in depth as to why that does happen and options to suggest to your client that would be better for them to use in their skincare regimen. So estheticians need to know about the pH so that they can select the use of products that will restore and maintain the natural pH of the client's skin. Also in this lesson, we're going to be able to explain the effects that acids and alkalis in water and how they react and their relation to the pH scale. Also summarizing the significance of the pH scale, including measuring, balancing, and the effects of pH on the skin. And our main focus here is going to be how pH basically starts with water and going more in depth with the actual pH scale. So all estheticians need to be familiar with the different forms of cosmetic and skincare products that are available. And this means understanding the chemical combinations and ingredients that will contribute to the beneficial or not so beneficial results of using each product. With this knowledge, you can determine the intended effects of the products and simply by reading the ingredients label. To use products correctly, it does help to understand the pH, product types, and cosmetic regulations. In this lesson, you will learn about the pH and its relationship to the environment and how it's in relation to skincare products. So the pH starts with water. pH stands for potential hydrogen, and it's a numerical measurement that indicates the acidity or the alkalinity of a water-based substance. So this only works with water-based products. It does not work with oil-based and according to how to measure it. So pH does play a big part in our daily lives. Cosmetics, household cleaners, medicines, fertilizers, water purification chemicals, pet care items, and many other products must be within a certain pH range to work effectively. If they aren't, they can be damaging and possibly even deadly. And the pH value of products is the most common method of identifying their appropriate use for the skin. Only solutions containing water or solutions that have been dissolved in water can be acidic or alkaline in value. And since water is the primary ingredient listed on many industry product labels, most of these products will have acidic or alkaline values. So why do different substances have different pH values? pH starts with the behavior of water, which is again H2O, like we talked about yesterday. So we have a water molecule, which is H2O, but when we break it down, we actually have 1 part hydrogen and we have 1 part hydroxide. So we have a negative and a positive ion. Water molecules have 2 hydrogen atoms and the 1 oxygen atom. It's natural for a small percentage of the water molecules to split apart and resulting in a positive hydrogen ion or an H plus and a negative hydroxide ion OH negative. So this illustration represents a glass of pure distilled water. Most of the water molecules, which is H2O, will stay intact, but some of them will split apart or ionize. H plus and OH negative ions can also come back together to form water molecules. And because this is pure water, the breaking apart of H2O molecules will always result in a 1-to-1 ratio of positive H plus ions and negative OH negative ions. And that's why pure water is considered a neutral substance. The positive and the negative ions actually balance each other out. So water is pretty much just neutral on the scale. So on the Discover More, it says the human stomach contains hydrochloric acid, and that's there to actually help digest food and kill certain bacteria, which keeps humans from getting sick. However, too much hydrochloric acid can lead to indigestion, and so the acid can also be neutralized with an alkali, such as an indigestion tablet. So acids and alkalis change the balance of hydrogen and hydroxide ions in water. An acid is a substance that increases the concentration of hydrogen ions, and when placed in water, because it donates or releases that H plus ion, an alkali actually decreases that concentration of hydrogen ions. And when they're placed in water, because it accepts or combines with that H plus ion, it results in fewer loose H plus ions and proportionately more OH negative or hydroxide ions. And when acids and alkalis are brought together, they actually neutralize each other. So acids do tend to taste sour and they react strongly with metals. Alkalis do tend to taste bitter and feel slippery. And strong acids such as hydrochloric acid and strong alkalis such as lye can burn. So a solution is acidic if it has more positive hydrogen ions than negative hydroxide ions. And when a solution has an equal number of those positive and negative ions, it's considered neutral. And if a solution is alkaline, it has more negative hydroxide ions. An anion is a negatively charged ion, and a cation is a positively charged ion. And this is important to remember when using galvanic current. So the pH scale. So acids and alkalis have been around for ages, but the pH scale is relatively new, and it was invented in 1909 by a Danish biochemist named Soren Sorensen. The pH scale is a quick way to understand the degree of acidity or alkalinity of a substance without needing in-depth knowledge of that molecular changes that can be involved. So distilled water has a neutral pH of 7, and pH values below 7 will actually indicate more acidity. A higher concentration of H plus ions and OH negative ions will be present. pH values above 7 actually indicate more alkalinity and a higher concentration of that OH negative ion and the hydrogen plus ion. The closer that you get to 0, the stronger the acidity. And the closer that you get to 14, the stronger the alkalinity. So it's important to know that the pH scale is a logarithmic scale. And this simply just means that each change in value along that scale is in change of 10 times. So a pH of 2 is 10 times more acidic than a pH of 3. It's 100 times more acidic than a pH of 4, and 1,000 times more acidic than a pH of 5. So likewise, a pH of 9 is 10 times more alkaline than a pH of 8, 100 times more alkaline than a pH of 7, and 1,000 times more alkaline than a pH of 6. Really, to make it more simple, when you're starting on the acidic side, it's going to go in values of 10, 100, 1,000. And then if you're starting from the alkalinity side, which you're basically counting backwards, you're going to start with the 1,000, you're going to go to the 100, and then you'll go to the 10 until you actually meet in the neutral, which is the 7. So here is a scale for you to look at. These are some pH value examples. So more acidic is always going to be more on the red side, and more alkalinity is going to be more on the blue side. 7 is always neutral. It's found in the middle of the scale of 0 to 14. So some examples of acidity would be like a lemon. That would be considered in between a 2 and a 3. What you do need to know for your test is that hair, skin, and nails is on a pH of 4.5 to 5.5. So even though you might think acids are bad, there are actually some that are beneficial, and that is where our skin likes to live. Now, the inside of our body likes to be more in an alkaline state, okay? So that's why alkaline waters, they do suggest alkaline diets are better for us internally, but externally, acidic products are going to be more beneficial. So the pH scale is a logarithmic scale that ranges 0 to 14, and substances with a pH that are less than 7, again, these are acidic, Substances with a pH more than 7 are alkaline, and substances with a pH of 7 are considered neutral. You do need to know this for your test, that it is 0 to 14, and acidic is 0 to 6, and 8 to 14 is alkaline, as where 7 is going to be neutral. So we can measure the pH of a product, and how we do that, there's 3 different ways. You can actually buy a pH meter. You could use a universal indicator solution, or you could use a universal indicator paper. So the pH meter is considered the most accurate of the 3 methods. An electrode is placed in the substance to be measured, and an immediate pH reading will appear. It can also measure the pH of the acid mantle that coats the skin and the hair. And universal indicators use a blend of several compounds to actually identify the pH of a product. A range of color does change indication differently on the pH levels, depending on where it's at on that scale. And the use of color matching charts will help determine the pH of various products. So universal indicators can also be in the form of a solution or a paper. Litmus paper is a well-known type of indicator paper. This is probably the most common that estheticians do use. You can purchase this on Amazon. You can even get it at like a pool store. You're just testing basically like water or any water-based products. So litmus paper is well known. However, it can only determine whether something is acidic or alkaline, not the numerical pH value. So it can't tell you the actual numerical number, but it can tell you whether by color, if it's an alkaline or an acidic product. So if that litmus paper is blue and it turns to red, it's more acidic. And if it's red litmus paper that turns more blue, it would be more alkaline. It says nitrazine paper is a more specialized indicator and can provide a specific pH number. So pH balance within the aesthetics industry refers to a product with a pH of 4.5 to 5.5, which is again hair, skin, and nails. And your task as an esthetician will be to use products that help maintain the pH balance of the skin in the 4.5 to 5.5 pH range. When you're using alkaline products, it's important to restore that pH balance once the service is complete. Also keep in mind that in order for a product to have a pH rating or be tested for pH, it must contain water or have the ability to dissolve in water. So your industry connection or salon install products, acid-based products like chemical exfoliation or acid peels will take the skin to an acidic state, which induces a wound on the stratum corneum or that top layer of the skin. And this signals to the skin that new cells need to be produced, which in turn will help reduce the signs of aging and sun damage. So the pH value of these products usually range between 2 and 3 and should be applied as part of a professional salon spa service. Alpha hydroxy acids equal reduction in signs of aging. pH effects on the skin. Harsh soaps and cleansers are relatively high pH products, which will strip that protective layer of the acid mantle during the cleansing process. So when this changes the skin's pH to an alkaline level, it increases that skin's permeability or its ability to allow liquids or gases to pass through it, which basically in the state, if the skin is there, it's more vulnerable and it can actually be susceptible to injury from environmental factors like the weather. If your skin's already compromised on that acid mantle and it's cold outside, your skin might become irritated, it might become red, it could become inflamed, and also it can maybe have that same feeling as a windburn or chapped skin, like chapped lips. So this is a mild this is why mild pH balancing toners or a moisturizer should be applied after using a high pH product such as soap or cleanser, and most will have slightly acidic pH, which will help to restore the skin to its natural pH range of around 4.5 to 5.5 after cleansing. At this pH, the acid mantle will function at its optimum level, and it also maintaining an effective protective barrier for the skin. So every organ and tissue of the human body is made up of mainly water, including the hair, skin, nails, the brain, the muscles, and blood. Remember that the body makes up more than 75% of just water. So you can determine the acidity or the alkalinity of all these once you understand that pH level, and knowing whether a product is acidic or alkaline will help determine the appropriate products to use to help keep your client's skin looking its best. So we learned that acids and alkalis are substances that do change the balance of hydrogen and hydroxide ions that happen in water. The pH scale is a logarithmic scale that ranges from 0 to 14, and substances with a pH of less than 7 are considered acidic. Substances with a pH of more than 7 are considered alkali, and substances with a pH of 7 are neutral. pH values can be measured with a pH meter, universal solution, or paper. Estheticians do need to be familiar with the pH of products in order to select and use the appropriate products when performing client services. And also, the skin functions at an optimum level in maintaining an efficient protective barrier when it's restored to its natural pH range of around 4.5 to 5.5.